All right, well, let's keep this train moving. Conversions between radians and degrees. When in doubt, go with this. So pi over 5, that's not really one of our automatics, so what we would think about doing is substituting 180 in for pi and then just doing the math. So that's 720 degrees over 5, which I don't. Now, pi over 2, that should be easier. If you want to, you can just plug in 180 for pi. But pi over 2 is referred to as an automatic, which should just pop into your head as 90. So that'd be 20 degrees. These might be a little bit harder, but remember our automatics, pi over 6, 60 is pi over 3, and 45 is pi over 4. So what goes into 210? 30. If that doesn't jump into your head, you can use pi over 180 or 180 over pi, depending on what you're doing. Now we're trying to convert degrees to radians, so you could think of it like this, and then here's what we want. We want pi over 180 degrees So 305, we have to use this technique because none of our automatics go into that evenly. If you wanted to check, it would seem like maybe 45 does, but it doesn't, because 315 is what 45 goes into. So we're kind of stuck. I didn't put that over here. So it should have been 7 pi over 6 radians, but I don't get too hung up on that. Alright, so this is going to get a little weird, but 5 goes into 305, so 305 divided by 5, 61. And radians. Now, they might, this is what I'm a little worried about, have you convert that to radians in like a numerical way. So that would be 61 times, I'm going to find pi, for 1 radian is approximately 60. It's a little bit of a terrible approximation, but it's a good guess, because what's 5 times 60? 300. So 5.32 radians looks like it should be right around 305. It's just a little bit of a confirmation that you're in the ballpark. And now 24 degrees over 1, and we're going to go for 180, 6 for sure, 12 yes. Does 24? 180 divided by 24, 7.5. No, so 12. What about 180 divided by 12? 50. Composition of functions. So here we go. Start on the inside. That's saying let x equal -2 and pop it into f. So that means right there, because here's f. So -2 squared is 4. Add into f again. So 19 squared is 361. It's going to take a little bit of work here. So just to confirm this, 19 squared, 361. Now we do need to multiply that by 4, and then add 3. So it'll be 1,447. Next one, got to start on the inside, find h, it's right there. All over 2, which is the square root of 1 over 2, which is just 1/2. And that's the answer to the inside stuff. Quick sneeze. That was a doozy. All right, so we're going to pop a half in now. So this turns into g of 1/2. This is 7.5. Now this is a weird one. Take g of x, all of it, and put it into f. That's what it's saying. So it's really saying find f of all of this, 5x minus 10. So we got to put that into f wherever x shows up, which is right here. So it's a little bit of a pain, but it's 4 times 5x minus 10 squared plus 3. Two dangers. Number one, don't you dare distribute 10, 5x minus 10, FOIL that out. 25x squared, I'm going to go outside, inside, that's -50, and -50 is -100x, and then -10, -10 is plus 100. Now we can distribute that 4 through there. So that'd be 100x squared minus 400x plus 400 plus 3. So it's 100. Okay. Using the functions from number 18, how can you use compositions to show that f of x and h of x are inverses? Give me a second here. Okay, so the rule is something interesting is going to happen if we find f of h put on, and something similar is going to happen, and let's just check into it. So what's h of x? H of x is the square root of x minus 3 all over 2. So we replace that with what it is, and now we stick that into squared. If you square root, the roots fly off, so you get x minus 3 all over 4 times 4 plus 3. Now notice, these cancel, and you end up getting x minus 3 plus 3. Well, these so f of x, what is it? Well, it's this crazy thing. So this problem turns into h of 4x squared plus 3. So what does that mean? We got to put that into the function defined by h wherever x pops up, which is right there. So we take that x out, we replace it with all of this. So we cancel. So we have the square root of 4x squared. which is just 2x all over 2. These 2's cancel, and we get x. Both times we get x, so therefore they are inverses of each other. And that's one of the rules. The other rule, and I'm not going to do it, but if we graph this and we graph this, they'll be h of x, type it in, and they're going to be mirror images if you flip it over the y equals x line. We talked about that in class, but I'm not going to bore you to absolute death. That's it for your Unit 1 review. See me if you have more questions about this, though.